hello to our wonderful audience out there across the United States and even from Europe. We're so delighted to have you join us. Welcome to the CIDCI online salon. Uh, I'm Margie O'Driscoll, and on behalf of the CIDCI Board of Directors, I'd like to welcome you to CID's first online salon. We're really happy to have you join us on this grand adventure. Before we begin, we really want to acknowledge what a difficult time it is for many of you who are now juggling homeschooling, caring for elders, your day job, and all of this from your home and maybe from your dining room table like me. It's a lot. The pandemic is, for many of us, the most terrifying event that we've ever experienced, with deep disruptions in virtually every aspect of our lives. We urge you to be compassionate with yourself as well as those you live with. Our community, working together, will survive. Tonight, our hope is to provide you with an inspiring idea for healthcare facilities at a time when we're all thinking about hospitals and the heroic work of the men and women on the front lines of saving lives. CIDCI started this salon series as a way to hear great ideas from innovators in the built environment. Even though the people you hear from might not do exactly what you do, their ideas and provocations can, and we hope, will spur you on to a different way of thinking about your work every day. We'd especially like to thank our sponsors who make this salon series possible. Our presenters, Raftery, and David Chambers will introduce themselves, and then they're going to share a presentation on CareCyte, and from there we'll open it up to questions. Okay, everybody ready? Let's go. Without further ado, please join me in welcoming Chris Raftery, who will begin this presentation on CareCyte, a unique system which addresses the need for flexible medical facilities, especially in non-urban areas, which we know are acutely impacted by COVID-19. CIDCI board member Dean Reed describes Chris as a builder's builder, and I can think of no higher compliment, and what a wonderful way to introduce him. So take it away, Chris.
Well, thank you very much. I'm very pleased to be here. I know Dave is too, and we thank you for the opportunity to speak to you. I thought I'd introduce myself and give a little background first, then have Dave do the same, and then we can get into the genesis of CareCyte and what we were hoping to accomplish with it. So I spent some time in the Navy, and when I got out of the Navy, I went through the Carpenter's Apprenticeship Program and worked as a carpenter and carpenter foreman and general foreman. I liked construction work and building things and working with my hands. So I went back to school and got a degree in what was then called building construction at the University of Washington. It's now called construction management. And from there, I was privileged and fortunate enough to go down to Stanford and get a master's degree in civil and structural engineering and a concentration in construction management, which is where I met some of the folks at CIDCI. Upon graduating, I went to work for a general contractor as a superintendent and worked on some major hospital projects as well as others. Cedars-Sinai Medical Center in Los Angeles was one of the first large projects that I worked on. And then St. Michel Winery here in Seattle, and the 35-story 1111 3rd Avenue building and 48-story First Interstate Center. And throughout that, I worked as a superintendent for a long time, and then worked my way up as a project manager and then operations manager. So I've had a lot of experience, hands-on experience in construction with a lot of different types of construction, which I think has all been synergistic for my career, especially since I've always tried to look at things in ways that we can build things better, faster, and less expensively. So Dave, why don't you give your background, and I'll be quiet for a moment.
Okay, well, like Chris, I also was in the Navy, and after getting out of the service, I decided to go back to college at the University of Nebraska and complete my degree in architecture, which actually I started before I left for the service. And I did my first hospital project actually in 1983 and won an architectural AIA design award. And I was really full of myself. But I went back there a couple years later touring it with some potential clients, and and the facility looked as beat up as the place that I'd replaced. Maybe that's a little bit of an exaggeration, but it was pretty beat up. And I began to think that as architects, we weren't really solving the problem. We were just basically perpetuating it in terms of creating environments that really did not solve healthcare or healing as a healthcare process very effectively. And so that kind of began my journey of really assessing basically how healthcare works. I asked, lean, they talk about asking the five whys. I think I asked about 10,000. And ultimately, that led me on a path to creating some really interesting planning concepts, which led me ultimately to become what would be equivalent to the chief architect at Sutter Health, and which is 30 hospital system in Northern California. Margie, you're really familiar with them. And I did that for 10 years. And during that 10-year process, Sutter had hired me to basically use them as a lab to assess the potential for improved operations and encoding those operations into architecture, which is what I had been doing before I joined Sutter. And while I was at Sutter, Chris and I got an invitation to join the Seattle Science Foundation and see what they were up to, and I accepted that invitation. And I met Chris Raftery there. The Seattle Science Foundation is where we actually developed what we're calling CareCyte today, and that's kind of just a really brief on my background. I've actually also written a book on the concepts of lean healthcare and the way operations could be dramatically impacted by basically reducing handoffs and eliminating queues. But that's probably another discussion. So I'll turn this back to Chris and we can get started, and I'll share my screen. How's that?
Sounds great. I'm going to talk briefly about CareCyte and what prompted us to work on CareCyte. Then I'm going to step back and talk a little bit about the genesis of it, because I think it's important to understand how the concepts work on a practical basis to design and construct the kind of facility we're talking about. As a superintendent in construction, I worked on a variety of different projects, and I first got interested in computers in construction a long time ago when we were doing one-sided wall forming and putting embed plates on the forms. And of course, we'd pour the concrete forms off, and the embed plates would all be in the wrong spot, simply because it was a mirror image kind of thing. And so I thought if we had a computer, we could model it looking at it face to face and then flip it around so that the carpenters could actually measure out exactly what was there. So I've been interested in computers in construction and design for a long time. I had the opportunity to work on a number of different medical related facilities and research facilities. I was a superintendent on the first medical research laboratory to culture the AIDS virus for AIDS test kits. And I also worked on a large semiconductor plant down in Portland for Fujitsu, where we built a 85,000 square foot class 1 0.1 micron clean room. Why that's important is, as it relates to CareCyte, is I learned the importance of isolating spaces and developing clean air strategies. So during the course of my construction work, we put a proposal together to build the Experience Music project, now called the Museum of Popular Culture, for Paul Allen. It was a free-form Frank Gehry design, where at one point Frank said, if there's a straight line in the building, or you find a straight line, please let me know it's a mistake. So Frank designs in a medium called CATIA, which is the same kind of programming that Boeing uses for design and development and manufacture of the 777, the 787, Freightliner, Dodge, a number of other large manufacturing companies use it to design and control the manufacturing of their facilities. So this was turned out to be a 140,000 square foot facility steel structure. These are the wire model diagrams of it. And up in the upper left-hand corner, those sketches were the first sketches that Frank gave in a meeting and said, "This is what I want to build." Below that is a model of the facility, which looks remarkably like what is built there, which is, I think, what's supposed to happen. But what we did was we invested in 6 CATIA stations at the time, and we developed protocols so that we could put all the pieces together in a way that what we came to call assured fit. So this is what you're seeing now is pictures of the structural steel that went into the building, and in the top left corner is the manufacturing process. We couldn't buy this steel. Nobody offered it to us. We couldn't take steel shapes and bend it into place, so we made it ourselves. We took steel plate and used the computer to cut the plate into the proper shapes and form, and you can see how wild it is. We developed the connections ourselves, and the remarkable thing about it was that when we erected the structural steel, there wasn't a single piece that didn't fit perfectly. Uh, and I built a number of buildings that are rectilinear in form, boxes if you want, where 4 to 5 to 6% of the steel didn't fit. And what was remarkable to me about this was that I thought that if we could do this on this kind of a building, that it would allow us to hone the tolerances down uh, in the balance of the construction work that we do, design and construction work that we do, to enable prefabricating parts and pieces for buildings so that we were assured that they would fit out in the field. And if you have assured fit, then there's all kinds of pieces of equipment that you don't need. You sure don't need a cutting torch if you know that it's going to fit. And and so one thing led to another, and I was at a invited to a breakfast where I happened to sit next to a fellow by the name of Dr. Bob Franza, who was a research science medical doctor, and at one time he was the second or third most referenced researcher in biomedics in the world. And he was telling me what he was doing at the University of Washington and at the Seattle Science Foundation. Not that I understood a lot about molecular biology. And I shared with him some of the things that I was doing and interest in prefabricating and how 4D modeling fit in, and the experiences we had at the Experience Music Project. And he gave me a homework problem. He said, would it be possible, do you think, to prefabricate a healthcare facility so that we could deliver a working hospital someplace where there is no healthcare? And we envisioned sending it to rural Africa or India or any of these kinds of places that really didn't have access to healthcare. And I said to Bob, well, let me think about it and let's come back and talk. So I did, and I met with him a few days later, and he brought several other people with him, 2 of which were Nobel laureates, including Dr. Lee Hartwell, who at that time ran the Fred Hutchinson Cancer Research Center. We talked about panelizing systems using the dimensions of a container, not the container themselves, but the dimensions of the container, which would allow us to ship virtually anything that we prefabricated any place in the world relatively economically for assembly. And they got so excited about it, we formed the study group that Dave mentioned and worked out of the Seattle Science Foundation for a year, developing the concepts that we did. So essentially what we did was we developed a modular prefabricated facility that could be shipped virtually anywhere in the world and set up to treat patients, including operating rooms, patient rooms, different modalities, which I'll let Dave talk about. The unique things about these facilities were that the air was clean. They were inexpensive to build. They were repetitious. They used all of Dave's revolutionary ideas for cellular care that I'll let him talk about. And they could be put up quickly and inexpensively. Go back to some of my notes here. So the doctors were interested in these kinds of facilities because I think it's not well known that even in the United States, there are so many areas in the country that are underserved. And in fact, in the state of Washington, we were told that every single county except for King County was underserved in terms of the medical facilities that they had. So and in fact, Dr. Greg Foltz, who ran the neurosurgery department at Swedish Hospital, said, "Don't send the first one overseas. I want a facility north of Seattle because when I go into Snohomish County, I don't have the proper facility to deal with many of the patient care issues that I have to deal with." So that gives you an idea of what was motivating this. Dave, why don't you take it from here and tell the folks a little bit about the facility itself?
Okay. I do want to emphasize what Chris was saying about the serious, basically void of healthcare capabilities in rural America. Since 2010, 80 rural hospitals have closed, and another 673 are on the brink of closing, which is approximately 40% of all rural hospitals. That's a tremendous issue, or maybe the word would be horrendous issue facing rural America. But the facility itself, if we go to that, I'm going to just blow through those kind of things, offers an opportunity. There's something that's really important to say here. We're not talking about a temporary facility. We're talking about a permanent facility. And we're talking about a facility where with Chris's really outstanding capabilities and intellect, he came up with the concept of using the container not only to ship the materials in, but as a box girder to actually hold the facility up. So what we ultimately created was a module that was 80 feet by 80 feet, so 6,400 square feet of space that is not encumbered by a single column, and therefore offers us the opportunity to create a fairly expansive a set of activities within that 6,400 square foot footplate, which, by the way, can be adjoined by another one and another one and another one. They're scalable, especially horizontally, just about as much as you could hope to be scalable, which offers us the opportunity to create a facility then that is permanent. We'll show you a small video if we have time for that at the end of this, which kind of like helps you visualize the facility. But the box girder then basically allows us to suspend or to hang a deep-celled cold-rolled deck off of each end of it, creating these 80-foot plates. But the deck itself then also offers us the opportunity to have an interstitial space without ductwork, but the cells can be a pathway for the air to be fed. So that in effect, every system has more than one function to it. We don't have the waste of a lot of separate discrete systems that then have to be basically configured to work with one another. The system itself allows that working to occur because the system itself is that deeply integrated. The other thing about this is that the design and planning is based on lean transformation, and that I'll get to that in a minute. But our guiding principles, let's talk about those for a second. Form ever follows function. That's a mantra given to Frank Lloyd Wright, actually, by Louis Sullivan at the turn of the last century. And I think that we've failed to acknowledge how important that is in healthcare as architects, and we've tended to basically create these plans that are just the result of order taking, where we meet with discrete user groups and we ask them what they want, and then we basically incorporate that into a building that also conforms, hopefully, to code. And that's basically our solution. That's not the way we should be looking at this problem at all. We should be really looking at how do activities and processes actually work to solve the needs of getting a patient a completed outcome. And as a result of our failure to look at things that way, we've created a lot of unnecessary redundancy in the spaces of our buildings. If we eliminated those unnecessarily redundant spaces, like for example, large waiting rooms, multiple check-in points, all those things could be rethought, because in effect we're just duplicating those processes over and over and over again, because we're looking at them from the perspective of each discrete department providing that service for themselves, rather than understanding that patients aren't broken down by department. They have a single body, and what's needed to be fixed is something that, from a patient's perspective, I've got this problem. Why don't you just take care of it? So so that's a very different way of looking at patient flow, and the result is that we could basically, I kind of talked about this already, but we could use this integrated facility that has multiple functions for each system, or with fully integrated systems, and we can also package it in such a way that basically this is the idea. If we create a building that has very efficient and effective patient flows in it, then we can also organize our staff to produce those flows really efficiently and effectively. So one of the things we want to do in that is we want to when we want to reassess basically flow, so that we don't have a lot of extra movement. As a matter of fact, we shouldn't have any extra movement, and we should also basically be flowing services effectively. And in the case of rural healthcare, even incorporating the expertise of urban and suburban physicians into the model using telemedicine. I think it's really interesting that as a result of the coronavirus, I'm getting emails constantly from different providers who are saying, and now we're going to be offering telemedicine. Well, they actually could always offer it, but it hadn't been paid for in the past, so therefore they weren't offering it. Now insurance providers are saying, "Hey, let's start paying for this," and sure enough, they're offering telemedicine, and it's a pretty effective way of providing a lot of healthcare without having a lot of extra movement. These are the impacts on facility metrics from the CareCyte model. We just looked at a program that accommodated 25 beds, just as a model to compare, with 2 ORs, 2 imaging modalities, and 15 ED exam rooms. And the total area in a conventional facility is 58,000 square feet. And in the CareCyte model, it's 26,000 square feet. That's a pretty substantial difference. And then when you look at the impacts of the cost model, the annual salaries and benefits are substantially reduced by roughly 35-40%. The annual capital costs are actually they're only a third of what they typically would be, approximately. So the annual savings are really astounding. And when you start to look at this, especially in the case of rural programs that may have some primary care capability but almost no secondary care or specialty care capability, by integrating telemedicine and by having those primary care caregivers become the hands and the eyes of the specialist, we can start radically reducing a lot of extra movement. We can start providing much more extensive healthcare in rural communities, and we can do it in facilities that offer us the opportunity to do so without a lot of handoffs and waste, which means better cycle times for the care delivery model itself, and for less expense. That's kind of a win in all fronts. So this is kind of a really quick. I know I'm kind of jumping through this fast, but I wanted to offer as much time as I could for questions. This is a little example of again, this is just a prototypical facility. It hasn't been actually developed to any specific program specs, but in this case, we have 2 exam rooms, we have 2 diagnostic modalities, we have we have 10 exam rooms. Now, an important thing to note here is you don't see anything that says emergency services on it, but in this concept, which actually has been done, it has been done in a hospital in Saskatchewan, Canada. They created a regional facility based on these concepts, with 35 universal care unit exam rooms in them, each single bed. And that's another thing about this solution. Every single patient care space is a single bed space. No multiple bed wards. So we have the opportunity to create an isolation level service capability in basically in every room in this facility. Again, we have to rethink some of the ways we're restricted by the kind of the legacy approaches to code requirements, but this is all doable. And the end result was that this whole everything you see in this little diagram here fits in 2 modules at 12,800 square feet. So it's 10 inpatient beds, 2 ORs, 10 UCUs, and the UCU then is both emergency services as well as prep and step-down recovery services for procedures and diagnostics. So that's kind of how this thing works. I'm gonna we'll talk about.
Let me interrupt you for a second, if I could, just briefly. If you recall, one of the reasons we used the 25-bed hospital as a model is that was about the size of the critical care hospitals that had been built, during the 40s, 50s, and 60s throughout the United States. They were all 20 to 25 or 20 to 30 bed hospitals. So we thought that would be a good comparison for the study. So that was one of the main reasons.
Yeah, that's a good point to bring up. But the bottom line is that regardless of what scope you have, this thing really is a kind of in my opinion, a really eloquent solution that again reduces waste and basically improves the potential of operating a facility with much less complexity and yet accomplishing very high level outcomes.
When we modeled all the different components and the panels, parts and pieces and everything, we estimated that all the components could fit in 17 high cube volume containers to be shipped just about anywhere in the world, and then reassembled on site using a minimal amount of equipment, no cranes, forklifts, maybe a squirt boom or something like that, but very simple to put together. The factory where these would be built would use highly skilled labor and equipment, but out in the field it would take ordinary labor just to put it together, and they went together very fast.
Should I show the quick little video or not?
Please.
Can you hear it?
Imagine being able to order healthcare facilities like we might order a custom car. The animation you are watching offers this idea as a real possibility. This is the CareCyte concept. The facility, once ordered, is manufactured as a kit of standardized parts and shipped to the site in shipping containers. These containers not only house the parts, they are the actual structure off which the building enclosure is suspended. This idea provides for significant long spans, that space that is not blocked by columns for 80 feet in any direction. These 80-foot square models can be joined to provide phenomenal flexibility. Standardized room types are made from plug-and-play partitions on a half-meter grid. The layouts are based on team care concepts that minimize patient movement and allow for smaller building footprints. Mechanical and electrical systems are fully integrated into the structure, and through decoupling the care technologies from the building, all systems are simplified. These ideas provide for permanent facilities that are quick to market, easily changeable, expandable, and much less costly than traditional healthcare buildings.
One of the questions that we received is why hasn't the system been implemented?
Yeah, great question. Chris, do you want to take that first, or?
Uh, there's hardly a day that goes by that I don't ask myself that question. We started the first meetings that we had talking about this took place in around 2004, 2005, and we met weekly and did a lot of work on our own, developed the concepts, and then proceeded to talk to a variety of different healthcare professionals, architects, healthcare architects, owners, hospital groups, and that sort of thing. We were fortunate enough, if I can put it that way, to get a commitment for $50 million in venture capital from a couple of major um, uh, investment banking corporations. Unfortunately, that commitment was given in late 2007. And as we proceeded from 2007 to 2008, the market conditions, as you may all remember, deteriorated, and the 50 million turned to 40, to turn to 30, to turn to 20, basically became zero. And so we were unable to get the capital to really further develop the ideas and to do what we wanted to do, which was build a prototype. And many of the healthcare providers were uneasy, especially because of the economic times, to try to consider putting some money forward in what they thought was experimental construction, even though every single one of the concepts that we had designed exists and is in common practice in some way, with the exception of the work, the computer work, and computer design work that we did to get the assured fit. So we virtually every presentation we made, we were applauded, and people were very excited about it, but not a single project came to fruition.
Well, that's, we had the Veterans Administration, the Department of Defense, the Bureau of Indian Affairs were all just really hot to become clients and to buy these things. But when they asked, well, where can we go see one and walk through it and kick the tires, it was kind of like, well, we don't have anything you can do that with. And they all kind of were skittish from the perspective of they didn't want to be the first.
We have another question that came in asking, why are the buildings focused on healthcare facilities over other types of buildings?
The Seattle Science Foundation had a really strong healthcare focus. As an architect, I've been focused on healthcare. They aren't certainly unique. They wouldn't necessarily only be adaptable to healthcare, but that was the primary focus of the team that actually was working on these concepts.
Let me answer that from a different perspective. There's been lots and lots and lots of time, effort, and study devoted to prefabricating just about every kind of building that there is. There's several companies down in San Francisco that are working very hard to develop a concept for prefabricating residential buildings and even office buildings. It's my personal opinion that the simpler the building, the less appropriate prefabrication is. And that may seem like a contradiction, but I'll tell you why. Easily prefabricating walls or even spaces and then shipping them to a location for assembly really doesn't take advantage of the prefabrication in terms of saving money. And in fact, what happens and there's several companies that I've visited and done some study with, many of these companies produce a 5 to 7 to maybe even 10% savings on the cost of construction in place. And then what happens is they ship it, and the shipping costs start to eat up the savings. And every one of them has a sphere or a radius of influence where, gone beyond that, the shipping costs eat up the savings. So for simpler construction, residential construction, and things like that, you need a factory that can produce things that are close to home. However, when you get into more complicated construction, things where you've got significant amount of plumbing and piping and head walls that you can create patterns and create a number of these things and then create big efficiencies in terms of the cost savings. The cost of shipping reduces significantly in terms of the impact on the overall facility. So it's our belief that the more complicated the facility, the more advantages there are to prefabrication, especially with assured fit and assembly in far reaches of the world even.
Another question we received is attendee very curious about wanting to hear further explanation of the MEP infrastructure, which they presume is integrated in the box beam structures.
It was integrated in the box beam structures. We used those box beams for a number of reasons. One was to support, provide both roofing support and lateral support for the buildings, but also act as a platform for all the mechanical and electrical systems. They're basically big bridge girders on each side that create a cavity so that you can put the mechanical and electrical equipment and a lot of other equipment that's necessary in there. You lift them up into place, and the mechanical and electrical equipment is, even though it's heavy, the box girders are so substantial it doesn't even know the stuff's there really. From there, the mechanical and electrical is distributed out through the ceiling areas, the interstitial space that Dave talked about. And one of the advantages mechanically is it's probably somebody from Southland that's asking this question, and they were a part of the study group for a while. We could tap into the air flow at just about any location in the ceiling and bring near laminar air into a room or an examination room or an operating room or that sort of thing. So it was extremely efficient in terms of the distribution.
Thanks everyone for submitting questions. We have one asking about the estimated prefabricated construction cost before shipping, including the materials.
Well, I'd have to go back into the memory banks. Dave, correct me if I'm wrong, but I think that our 28,500 square foot, 28 bed, 3 operating room facility ended up at $660 a square foot.
Between six, that was then. I'd say it'd probably be somewhere between 660 and 800, depending on the system integration that a client wanted. Because there is one other study group that I've been a part of, which would be basically eliminate the head walls themselves from the architecture by integrating those into a bed, so it becomes part of your equipment rather than your facility. But that's really the only difference between a fully integrated head wall system versus everything else that we're talking about, which should still be it'd be a difference in cost per square foot for the facility if you're not putting oxygen and vacuum systems through the walls. But that's really the only really big delta.
And the 660 was in 2008, 2009 dollars.
Yeah, that's right. So I'd say I'd err on the side of like maybe close to 800 at this point.
Yeah. It was very efficient.
I mean, when you're talking about, a 25 bed hospital for, roughly what, $18 million, that's in terms of what we're seeing, at least on the West Coast, that's like crazy cheap. That's impossible cheap, actually.
Jim Bedrick, one of the CIDCI board members, is asking, can you elaborate on the assured fit concept?
Yeah, that's actually a really good question. And let me start out by saying that one of the things that started the Industrial Revolution was the need to develop tolerances in rifles for fighting wars. And way back when, they'd hand make these rifles and somebody would take a bolt out or a bolt would get damaged and they couldn't take a bolt from another rifle because it wouldn't fit because the tolerances weren't right. We have some of the same kinds of problems in construction. The tolerances for the AISC and no knock on them because I'm a member of the American Institute of Steel Construction, doesn't allow for assured fit. If you use drywall, it's wavy enough to where it's hard to get it to fit unless you are fitting it on site. So what we found in the Experience Music project using the CATIA programming is if we followed the protocols that we set up so that the manufacturing process, rather than the construction process, the manufacturing process, the tolerances were fine enough so that everything would fit properly as designated by the computer. We manufactured to those tolerances, things fit. So it gave us the confidence to where one company could manufacture, say, structural steel, and another firm could manufacture the pieces that went, the envelope that went on the structural steel, for example. And we knew that when they got on site that they would fit. And in fact, that's exactly what happened. We ended up building the structural steel pieces down in an old Navy yard building down in Portland. And A. Zahner Company out of Kansas City, Missouri, did the skin, and we had CATIA platforms in each facility, and matched the pieces to the structure so that when they did come out, they fit fine. We had a few issues with temperature, which were solved by shooting a little cold water on the to get the expansive metals to contract. But other than that, things fit perfectly. So the idea behind assured fit is that you design these things to the point where, like a manufacturing company does, so that you know that they will fit, so that you can get the pieces from different vendors, and when they come together, they fit.
We have a question from Jay Love. Can you comment on the structural system in areas of high
Seismicity?
yeah, thank you. Or high winds?
Well, you know, whether it's wind that controls or seismic activity that controls, whether they're near fault or not, those big box girders, those grids are so substantial for a single story building, even though it's a tall, you know, floor to ceiling height, that they work quite well seismically and for wind.
Great. We have a question. You might want to punt this one to Dave because he knows the California regulatory environment, but it's a question from Jessica Kelly at Southland. What are the challenges, if any, with local code requirements for different? And would OSHPD ever accept this? Sorry. Sorry to.
Well, no, that's actually a great question. So I'm gonna answer that by telling a little story. And when the people in Saskatchewan contacted me and asked me to get involved with the work they were doing up there, I had told them about, you know, these cellular workflow concepts for healthcare, and they were very intrigued by that. But they knew that it would not get through code review in the Saskatchewan province. So they actually calendared a meeting with me with the Minister of Health in Saskatchewan, and I basically showed him the same, a similar kind of thing, a little more detailed on healthcare flows in particular. But at the end of that meeting, he scheduled it for half an hour. It ended up being an hour and a half. He got pretty intrigued by it. He put out a memorandum saying that all new facilities in that province would at least consider these alternatives as far as workflows and care flows were concerned. And he contacted basically the regulatory agencies and asked them to collaborate with us to basically come up with a viable solution that allowed them to regulate and yet still allowed us to get what we were trying to accomplish in this. That happened because somebody in government, basically somebody with responsibility, took it upon himself to say, this is an idea that's worth too much to let go of. That can happen in any environment. That can have, you know, I actually have very good contacts and actually some friends in the OSHPD environment, but quite frankly, Hodgepodge wouldn't be the biggest obstacle in California. It would be the Department of Licensing for sure. When we tried a couple of universal care unit concepts in California, we were met with resistance because they didn't fall under any one specific departmental guideline for licensing. So the reality is these things can be done, they can be coordinated, but we need in effect a burning platform before people start rethinking these things. I can tell you that in Saskatchewan, their burning platform was that they had 6-month waits for hips. They had emergency visits that with an average cycle time of nearly 24 hours. After they rebuilt that facility, after they built the replacement facility based on these concepts, their lead times for surgeries went down from an average of 6 months to 2 weeks, and their emergency cycle times went from 24 hours to 3. And they did not add a single person on staff in order for that to happen. So these ideas work, and they work really well, but you basically have to recognize that you're on a platform that's burning and you need somebody to help you fix it right away, or you're gonna suffer the consequences. And that's what happened in Saskatchewan. It could happen in the United States. I think this COVID-19 crisis may be having some people rethinking some of these things, like, for example, telemedicine, which is basically something that I worked with actually the province in British Columbia several years ago on telemedicine, and persuaded them to run a test pilot, for authorizing telemedicine for their providers. It worked so well, it became a standard of practice. So these things can happen, but we need people with a little bit of courage and to become vested in an idea that they think is worth it enough to follow through on it. So yeah, the regulatory pressures in California are intense for very good reasons. I totally understand why they're there, but that doesn't mean we can't rethink them in a time that basically necessitates change. Did that answer the question?
I think so, especially, there's been a lot of news in the last 24 or 48 hours about inequity within the healthcare system that's particularly impacting people in rural communities. So,
Oh yeah, it's terrible in rural communities. It's going to get worse.
yeah, you had said something yesterday when we talked about Boise, Idaho, having the highest per capita incidence right now of COVID.
It's the second highest per capita incidence of COVID-19 in the United States. It's not Seattle. New York is the highest right now, but the second highest in the United States is Boise, Idaho. And now Boise still has this basically urban capabilities within the city, but what that tells me is that it's moving out into our rural communities. And when it gets there, how are we going to help those people? That's a question we should always be thinking of now, because the cycle of this is, it's already hitting the cities, but it's going to hit the towns. And when it does, how are we going to help them? What's our answer for that? When all these rural hospitals are closing right and left. One of the advantages of CareCyte was speed of delivery. I mean, if somebody asked us to get going on this, we could have a CareCyte facility up and running in very short time. But more importantly, let's say right now that requester needs just a bunch of beds. So each module is capable of 10 beds, 10 single bed private rooms. But over time, let's say they decide, okay, we solved the COVID crisis, but we really need procedural capability out here too. All the partitions in the CareCyte modules are plug and play, and the floors are panelized, so that in effect, you could literally almost overnight change that from 20 beds of an inpatient med-surg unit to a 10-bed critical access hospital with a couple procedural rooms and a couple diagnostic imaging modalities, and a universal care unit that could provide emergency services as well. And that could literally happen on the fly.
Wow. We have a question here. What would it take to operationalize CareCyte today to meet the crisis?
Well, we'd have to have a contract that'll enable us to spend a lot of money really fast. But the other thing about this is that virtually all of these systems are actually existing in the world today. So it's not like we have to go out and like re-engineer or engineer a completely new concept. It's actually just taking the elements of components that we have today and just repurposing them in a rather new and very different way. So it wouldn't take a lot of time to do it, but it would take a commitment of money.
Mm-hmm.
Yeah, there's some design work that we would need to finish. We did all the basic design work some time ago, but manufacturing details and stuff and things like that for manufacture. I think that there are a number of existing industrial manufacturers where a factory could be adapted pretty quickly to produce these things. In the Northwest, I think the Kenworth truck manufacturing plant, which I was involved in the construction of a number of years ago, would be a good candidate. I think some of the Boeing facilities could be used. They have the equipment and the technology and the machinists, which played. We spent a lot of time negotiating and talking to the labor unions about how this would go together, and we ended up with a universal mechanic that would come under the umbrella of the machinists, because they had the widest capabilities in terms of the skill sets to put these things together. We could utilize them, and then it's just getting the supply chain set up and bringing the equipment in and manufacturing it. I think that might be tougher to do with the social distancing and things like that we have to do right now. But I think that it would be very smart when we get through this first bout of COVID virus to take a look at this thing and see how we couldn't put this thing together so that if something else came up, we could utilize these things quickly. These facilities are clean.
Even as it gets into its second wave.
Yeah, they're clean. You can isolate patients in them easily because you can move the airflow from positive to negative depending upon what rooms you're in. The air is filtered. Every single section of the building is filtered with using HEPA filters. So there's a minimal chance of transmission. We spent a lot of time looking at eliminating nosocomial infection with the materials and the airflows and the cleanliness guidelines that we used. I think that I guess I'm getting sidetracked a little bit with the basic question of how quickly we could do this. But once we got the designs finalized, the manufacturing drawings, and the supply chain set up, I think it would go very quickly.
As in weeks, not year. In weeks, not even.
Yeah, weeks.
Yeah, weeks.
That's amazing. I want to end here and thank you both so much for giving us hope and vision in this time when we need as much of that as we can possibly have. And we all hope that this goes forward and helps to do, as our governor says here in California, meet the moment that we're in.
Can I add one more thing, Margie, before we sign off? If anyone that's listening is interested in forming a small consortium of how we might put something like this together and get it put forward, I would welcome, both Dave and I would welcome talking with you, see how we could do this. I mean, our major interest was delivering healthcare to people that really needed it, and that hasn't changed. Thank you.
Chris, would you like people to contact me and then I'll forward their names to you, or do you want them to contact you directly?
No, through you would be great, if you don't mind.
Contact me through the contact link on the CIDCI.org website. I want to again thank Chris and Dave for really such an inspiring conversation today. It's quite brilliant, the work that you've done, and I really hope we can figure out a way to, like I said, as our governor says here in California, meet this moment that we're in. So with that, I'm going to adjourn our conversation. As always, please feel free to contact us at the CIDCI.org website through the contact link. And I'd especially like to thank Monica Zwissler for serving as our as our traffic controller today. Thank you so much.
Thank you all.
Thanks.
Thank you
Thank
all
you.
very
Thank you
much.
very much.
Okay, bye.
Bye.